Hello everyone. This video is a continuation of fundamental concept of nucleophilic substitution reaction. In this video, I am going to discuss nucleophilic substitution versus elimination reaction. Nucleophilic substitution and elimination reactions are competitive reactions. In a nucleophilic substitution reaction, leaving group gets substituted by nucleophile. So here we have taken tertiary butyl chloride. Well, chloride is the leaving group. So leaving group leaves a carbocation form. Then nucleophile attacks here. So here nucleophile is OH minus. So from alkyl halide we are getting alcohol by the nucleophilic substitution reaction. In elimination reaction, same way leaving group will be leaving and will be getting a carbocation. Now here OH minus is not going to act as a nucleophile. OH minus is going to act as a base. That's why deprotonation takes place. So when deprotonation takes place, here alkene forms. So this is called elimination reaction. In the elimination reaction, from alkyl halide we are getting alkene compound. These two reactions, nucleophilic substitution and elimination, take place together, but sometimes nucleophilic substitution dominates over elimination. Sometimes elimination dominates over nucleophilic substitution reaction. But in this video, I am not going to discuss about the factors which decide that which reaction is going to be dominated. In this video, I am going to discuss type of elimination reaction and the mechanism of elimination reaction. Let's explain the general mechanism of elimination reaction. Similar like nucleophilic substitution reaction, the substrate of elimination reaction also should contain a leaving group. Leaving group can be halogens or OH. Now the carbon which is connected with the leaving group is called alpha carbon. The next carbon which is connected with alpha carbon is called beta carbon, and the hydrogen which is connected with beta carbon is called beta hydrogen. So for elimination reaction, presence of beta hydrogen is must. Now this is a alkyl halide. So this carbon is alpha carbon because it contains leaving group. Now the carbon which is connected with alpha carbon is called beta carbon. Now beta carbon contains one beta hydrogen. So leaving group leaves and carbocation forms. Now here deprotonation will take place. Deprotonation takes place of the beta hydrogen. So here OH minus is acting as a base. So it will attack this H plus and beta hydrogen elimination will take place and we will be getting alkene. There are three fundamental steps take place in elimination reaction. First, breaking of carbon leaving group bond. Then removal of a proton. That proton should be beta hydrogen. And finally, the formation of carbon-carbon pi bond. Similar like nucleophilic substitution reaction, there are two types of elimination reaction, E1 and E2. E1 means elimination and unimolecular. E2 means elimination and bimolecular. E1 reaction is competitive with SN1 reaction and E2 reaction is competitive with SN2 reaction. Let's explain the concept of unimolecular and bimolecular reaction. The first reaction follows E1 mechanism. Similar like SN1 mechanism, here formation of stable carbocation is a crucial factor. And this step is the RD step. And in the second step, deprotonation takes place and we get alkene. So here rate of the reaction depends on the concentration of substrate. It is not dependent on the concentration of base. So that's why E1 reaction is called unimolecular reaction. Now this one, the example of E2 reaction. So for E2 reaction, similar like SN2 reaction, formation of stable carbocation is not the factor. So here leaving group leaves and deprotonation takes place at the same time. It's a concerted process and this step is the RD step. So here rate of the reaction depends on the concentration of substrate and the base OH minus. So that's why E2 reaction is a bimolecular reaction. As I have already mentioned that E1 and SN1 reactions are two competitive reactions. Now we'll explore these two reactions. In SN1 reaction, formation of stable carbocation is the crucial factor. This is the rate determining step. So that's why we take tertiary butyl alkyl halide or tertiary butanol. So first leaving group leaves and a stable carbocation forms, then nucleophile attacks here and a new bond forms between carbon and nucleophile. In E1 also, first step is the formation of stable carbocation, which is the rate determining step. But in the step 2, OH minus behave as a base, so deprotonation takes place and we get an alkene molecule. For both E1 and SN1 reaction, formation of stable carbocation is the rate determining step. And it has been seen that rate of the reaction depends only on the concentration of substrate. It is not dependent on the concentration of nucleophile in case of SN1 or not on the concentration of base in case of E1. That's why these two reactions are unimolecular reaction. In SN2 reaction, usually we take primary or secondary alkyl halide or alcohol. So here leaving group leaves and nucleophile attacks at the same time. So it is a concerted process and then finally leaving group leaves and nucleophile make a new bond with the carbon. Similarly in E2 reaction also, primary or secondary alkyl halide or alcohol is a suitable substrate. So this is also a concerted process like SN2. Here leaving group leaves and deprotonation takes place at the same time. Then finally leaving group leaves and a new pi bond forms between the two carbon. So this is the main difference between E2 and SN2 reaction. In the SN2 reaction, leaving group substituted by nucleophile, but in E2 reaction we get a alkene molecule. Rate of the reaction depends on substrate and the concentration of nucleophile for SN2 and the concentration of base for E2 reaction. So that's why both are bimolecular reaction. So finally the take home message from elimination and substitution reaction is that SN1 and E1 and SN2 and E2 reactions are competitive reactions. SN1 and E1 reaction proceeds via formation of stable carbocation. So that's why formation of stable carbocation is the slowest step or the rate determining step of SN1 and E1 reaction. In SN2 and E2 reaction, formation of stable carbocation is not an important factor. This reaction proceeds via a concerted process, and this is the RD step or slowest step of the reaction. Since formation of stable carbocation is not the crucial factor for SN2 and E2 reaction, that's why secondary or primary carbocation forms during this reaction, and that's why usually we take primary alkyl halide, secondary alkyl halide, or primary alcohol or secondary alcohol. Last but not the least, in nucleophilic substitution reaction, nucleophile substitute the leaving group of the substrate. But in elimination reaction, nucleophile behaves as a base. So it deprotonates beta hydrogen and form a alkene molecule. I hope this video will be useful for your study. It will help you to understand the difference and similarities in nucleophilic substitution and elimination reaction. If you like this video, subscribe my channel Chemistry Affinity and share it with your friends. Thank you for watching this video.